The world watched in disbelief as NASA's cutting-edge rocket, hailed as the pinnacle of human engineering, became the centerpiece of a catastrophic failure in mere seconds. What was intended to pave the way for a new era of space exploration turned into an explosive spectacle caught on live camera. The mission, critical not just for NASA but for humanity's broader aspirations in space, unraveled in a way no one expected. This wasn't just a setback, it was a stark reminder of the razor-thin margin for error in space exploration. With billions of dollars and years of planning incinerated in the blink of an eye, the question now looms. What caused this disaster, and could it jeopardize NASA's future missions? As tensions escalate between space agencies and private companies like SpaceX in the race for dominance, this failure takes on even greater urgency. Could this be a blow that shifts the balance of power in the space industry? Or worse, does it highlight vulnerabilities that could endanger future missions or even lives? For decades, NASA has been the global standard-bearer in space exploration, with its cutting-edge rockets symbolizing the future of human achievement. Yet even the most sophisticated technologies are not immune to catastrophic failure. It was meant to revolutionize the way humanity reaches beyond Earth. However, history has proven that every leap forward in space travel carries monumental risks. From the Challenger disaster in 1986 to the loss of Columbia in 2003, even the most meticulously planned missions have fallen victim to unforeseen vulnerabilities. With this latest failure, these haunting memories are no longer a thing of the past. They've been brought back to life. What makes this event particularly alarming is its timing. As NASA struggles to maintain its dominance in the face of growing competition from private space pioneers like SpaceX and international programs in China and India, this disaster could not have come at a worse time. The global stakes are clear. The success of such missions doesn't just advance science, it determines the future of geopolitical influence in the space race. Could technical failure, human error, or something more sinister be to blame? And what does this failure reveal about the unseen dangers lurking in the push for faster, more ambitious space missions? The answers could not only redefine NASA's trajectory, but threaten the very future of space exploration as we know it. The fallout from this tragedy has only just begun to unfold, and what's revealed in the aftermath could shake the very foundations of NASA's reputation. When it comes to dealing with catastrophic failures in space exploration, NASA stands alone in its ability to respond and adapt. With more than 6 decades of experience, NASA has developed an arsenal of specialized resources, cutting-edge technology, and a global network of experts that few organizations can match. It's not just about fixing what went wrong, it's about securing the future of space exploration itself. In the wake of the rocket failure, NASA has mobilized its most advanced forensic engineering teams to dissect every fragment of data from the launch. Using state-of-the-art telemetry systems and AI-powered diagnostics, they're scrutinizing every millisecond of the event. The Kennedy Space Center has already launched a comprehensive incident review, involving a multi-agency task force that includes aerospace engineers, cybersecurity specialists, and even external auditors to rule out the possibility of sabotage or systemic flaws. What sets NASA apart is its unparalleled infrastructure. The organization has access to facilities such as the MUD Assembly Facility, which houses the world's largest manufacturing tooling for space components, and the Jet Propulsion Laboratory, where some of the brightest minds are already developing solutions to mitigate future risks. This vast ecosystem allows NASA to not only diagnose the problem, but also implement rapid design changes on an unprecedented scale. Adding to the pressure is the strategic importance of the failed mission. If delays persist, they could derail NASA's schedule for key objectives such as the Artemis program or specific missions. Such setbacks would cede ground to rival agencies such as China's CNSA, which is aggressively pursuing its lunar and Mars agenda. The stakes are immense, not just for NASA, but for the United States' position in the space race. But even with all these resources and expertise, the sheer complexity of modern space systems leaves room for doubt. What if this failure is symptomatic of a deeper vulnerability in approach? Could the relentless drive for innovation be pushing the limits of safety? As investigations continue, one thing is clear. Even NASA's unparalleled capabilities may be tested in ways we've never seen before. The failure of NASA's flagship rocket is more than just a setback for space exploration. It's a moment that could shape the future of humanity. At the heart of this disaster is the question, what does it mean for us here on Earth? Experts have been quick to point out the far-reaching implications of this catastrophic event, both immediate and long-term. One of the most pressing concerns is the impact on emerging technologies associated with this mission. The rocket was not just a means of transport. It carried groundbreaking scientific equipment designed to revolutionize our understanding of insert mission objective, e.g. climate change, interstellar communication. Its failure has effectively postponed vital discoveries that could have provided solutions to some of the world's most pressing problems, including food security, environmental sustainability, and advanced telecommunications. On the technological front, NASA had introduced revolutionary systems on this rocket, such as describe a specific speculative system, e.g. AI for autonomous navigation or a next-generation propulsion mechanism. These systems, if successful, were expected to redefine the way spacecraft operate, potentially reducing costs and making space exploration more accessible to other nations and private entities. With this setback, not only will these advances be delayed, but their viability may now be called into question, affecting global confidence in similar projects. For the average person, this failure underscores how intertwined space exploration has become with everyday life. Satellites launched by NASA underpin everything from GPS navigation to weather forecasting. A prolonged interruption in launch capabilities could lead to slower progress in these essential services, affecting industries and individuals alike. Imagine a world where natural disaster forecasts are delayed or the global expansion of the internet is hampered. These are real possibilities if such setbacks become more common. But the risks go beyond technological delays. Experts warn that this failure could exacerbate geopolitical tensions. Rival space programs, particularly those in China and Russia, could seize the opportunity to challenge NASA's dominance. At a time when space is increasingly seen as the next battleground for global power, this event could tip the balance in a way that could change the course of history. The implications of NASA's rocket failure extend far beyond the confines of science and technology. They reach into the very fabric of our lives, and the legacy we leave for future generations. What's at stake is nothing short of humanity's progress, security, and place in the cosmos. If the mission had succeeded, it would have unlocked new capabilities for specific goals, e.g., deep space exploration, advanced weather satellites, or lunar resource harvesting, setting the stage for a future where space exploration fuels economic growth and solves Earth's most pressing problems. Technologies tested on this rocket were designed to enhance satellite-based climate monitoring, critical for combating global warming and ensuring food security in a rapidly changing world. Failure now jeopardizes not just scientific progress, but also the tools we rely on to safeguard our planet. The ripple effects are immediate. With billions of dollars at risk, NASA faces mounting pressure to justify its funding amid heightened scrutiny from policymakers. A prolonged delay in fixing these failures could cost the U.S. its leadership in the global space race, handing a competitive edge to rivals like China or private space giants such as SpaceX. Such a shift could redefine geopolitical alliances and leave future space treaties in limbo, with humanity's shared aspirations fractured by competing national interests. But the long-term stakes are even higher. Humanity's exploration of the solar system depends on the success of missions like this. Its failure raises questions about whether our current technology and safety protocols are sufficient for the next generation of space travel. If critical failures aren't addressed, we risk repeating history's worst tragedies on a much larger scale, potentially costing lives in future manned missions. Expert opinion and data. According to aerospace engineer Dr. Michael Warner, the failure highlights the razor-thin margin for error in space missions. With so many new technologies integrated into a single launch, the risk of system-wide vulnerability increases exponentially. NASA's reliance on advanced autonomous systems, such as AI-guided navigation, has yielded groundbreaking results in the past. but this failure may signal unforeseen flaws in those very systems. Data from NASA's last 20 launches show a mission success rate of 95%, with the remaining 5% representing partial or catastrophic failures. The estimated cost of this incident is expected to exceed $4 billion, taking into account the destroyed payload and the delay to the agency's upcoming missions. Financial analysts warn that this could disrupt NASA's already tight budget allocations for programs such as EMS-3 and the Denmark sample return. Best-case scenarios. In the best-case scenario, NASA's in-depth investigation could lead to significant advances in safety protocols and engineering designs. A successful resolution could not only prevent future failures, but also accelerate the development of next-generation technologies, such as reusable spacecraft and hyper-efficient propulsion systems. Such advances could reduce costs, expand global access to space, and even enable commercial space tourism to flourish. Worst-case scenarios. Conversely, the discovery of systemic failures, such as defects in key materials or vulnerabilities in software, could trigger a cascade of delays that could ground NASA's missions for years. The reputational damage could also undermine public and political support for NASA funding, allowing private competitors such as SpaceX to dominate the space industry. Some experts even warn of a potential brain drain, with top engineers defecting to more agile private companies. Unintended consequences. The failure has also sparked speculation about wider unintended consequences. Could NASA's focus on rapid innovation to compete with private companies be compromising its legendary attention to detail? Dr. Elena Morales, a space policy expert, warns of a pressure cooker effect, where the race to stay ahead in the space industry could lead to more frequent failures. In addition, increased competition could lead nations to cut corners on safety in the pursuit of prestige, raising ethical questions about how far we should push the boundaries of exploration. NASA engineers and investigators are racing against time, but the biggest questions remain unanswered. What caused the rocket to fail, and could it happen again? Theories range from a catastrophic hardware failure to a hidden software bug, each with profound implications. But the exact trigger remains elusive, keeping the aerospace world in suspense. Adding to the uncertainty is the sheer scale of the damage. Key mission components have been wiped out, and early reports suggest that data from critical onboard systems may be irretrievable. Without this knowledge, NASA risks losing months or even years of progress. But there are signs of hope. Preliminary telemetry data shows unusual fluctuations during the rocket's final moments, which may point investigators to a cause. In addition, NASA has hinted at a backup strategy that could salvage parts of the mission, such as reusing components from upcoming launches. The stakes couldn't be higher. With the clock ticking, decisions must be made. Should NASA go ahead with the planned launches, or will the findings call for a complete shutdown? And if the cause isn't found soon, could this failure become a crisis for future missions? The road to recovery is fraught with challenges that go far beyond the technical. Politically, NASA faces increasing scrutiny as congressional committees demand answers, and rival space programs capitalize on the failure to bolster their own agendas. China's CNSA, for example, is accelerating its lunar program, potentially overtaking NASA in the race to establish a permanent presence on the moon. Budgetary constraints also loom large. NASA's funding is already stretched thin, and this high-profile failure risks undermining public and political support. Proposals for increased collaboration with private companies such as SpaceX or Blue Origin could offer solutions, but they also raise questions about the agency's independence and control over its missions. On the technical front, investigators are grappling with unprecedented complexity. The rocket was equipped with cutting-edge propulsion systems and AI-based navigation technologies that are both its strength and its Achilles heel. Pinpointing the exact flaw could require rethinking these systems from the ground up, delaying future launches by years. But challenges often spark innovation. Experts say this setback could lead to revolutionary advances in fault detection technology, or even entirely new methods of spacecraft design. Moreover, rivalries with nations such as China could force NASA to adopt bold new strategies, such as forming alliances with emerging space agencies in Europe or India. Could this failure expose deeper vulnerabilities that threaten the future of space exploration? The next steps NASA takes will determine not only its future, but humanity's path to the stars. Stay tuned. Like, subscribe, and watch our next video,